Hi guys, this is a video for Chapter 8, Lesson 4. So in this lesson, what we're taking a look at is continuing off our our linear equations that we looked at in our last lesson. Really, we're looking at a graph and a line on a graph. And so anytime you see a line on a graph, you know it can come from a linear equation or a linear function. We're not going to be looking at the function itself today, but really looking at how a line changes on a graph. And so when we see a line that's on a coordinate plane, we can describe the steepness of the line as the rate of change. So for example, maybe my graph is like this, and it goes up, and then it goes like this, okay? So let's say we've got a rate at X here is 4, at B here, let's say this is 400, this is 500. And then this is at 2,000. And then this very top of this line here is at 24,000. Okay, so this is the vertical position. This is the horizontal position. Okay, so your X represents the horizontal and the Y represents the vertical, right? So when we're looking at the change of a line, we call that the rate of change. So we've talked about rates in the past. A rate is really just another way to describe a ratio or a unit ratio, unit rate. And so the rate of change is really a ratio describing the change that is seen. And so how you describe the rate of change is really the change in the vertical over the change over the horizontal. Okay, so in this example, if this were A right here, this is B, and I'm saying find the change, the rate of change that's going from A to B. To find the vertical change, we would subtract the ends point, subtract by the initial point. So that would be 2,400 minus 2,000. Okay, to find the horizontal change, that would just be 500 minus 400. So when we do this, we have 400 over 100 as the rate of change. Now the rate of change is always simplified, so that would be 4 over 1. Okay, so that means for every time it goes up 4 from one point to another, it goes over to the right 1. Every time it goes up 4, it goes over to the right 1. So that's basically the rate of change on our graph here. So let's look at our study guide. In this example, we're looking at the rate of change in this graph. So the pages red is the vertical change, and the time that's red is the horizontal change. So we see that basically you have to pick 2 points on your graph and then find the difference between the two. So if we look at the vertical change, we go from 0 to 24, or 0 to 8, sorry. So that would be 8 minus 0 as your pages. And then on our horizontal change, we go from 0 to 24. So that would be 24 minus 0. And so the rate of change is 8 pages. Every 8 pages you read, it takes 24 minutes. So when we simplify this, it's about 1 page per 3 minutes. So you can kind of see that 1/3 a page per minute. So, and this describes it. So you can look at rate of change without having a visual graph. You can look at it just by the chart. So if I were to look for the rate of change in the temperature, first of all, we have to decide what's our X, what's our Y. And thankfully this is labeled for us. This is X, this is Y, which means Y is the vertical change. That means we're going to find the difference in Y. So it'd be 6 minus 0 over 3 minus 0. And when we simplify that, that's 6 over 3 or 2 over 1. Or you could write it as 2. So for every 1 hour, the temperature goes up 2 degrees Celsius. That's the rate of change of time and temperature, how they change. So let's practice looking for the rate of change for these linear functions. One, we have a chart, and then the others, we have a graph. So with our chart, it's labeled for us what's X and Y, which means we're going to do the vertical change, which is Y, right? 3,000 minus 0 over 6 minus 0. Okay, so when we work this out, 3,000 over 6 simplified is 500, I believe. Let me just double check. Yes, 500. Okay, so it's 500 over 1, which means for every 500 miles, 1 hour passes. So basically it's 500 miles per 1 hour is the rate of change for the speed of, you know, this airplane flying or something like that. Okay, cookies needed. So when you're looking at a graph, the big thing you want to look at is just picking any 2 points. So you want to pick 2 points that are easily identified. If I pick the first point and the last point, that's really easily identified. I could pick, you know, this middle point if I wanted to and just compare the two. So let's do one where I have the first and last point. So my last final point on this graph is at 12 people with 60 cookies. So that would be 60 over 12 because I'm doing the vertical change over the horizontal change, right? 60 minus 0 and then 12 minus 0. So this would be 5 over 1. Let's just double check if I use different numbers, okay? So if I used this as my point and then this as my point, that my final position is at 60. And then I'm going to subtract where my initial position on my point is. So this point is at 20. And then my X is at 12 at the final point, and then this point starts at 4. So when I subtract this, I have 40 over 8, and when I simplify, I get 5 over 1. So see how the rate of change doesn't change really no matter which points you use. As long as you're subtracting them and finding the difference of the vertical change over the horizontal change, you'll get the same ratio. And so what this is saying is every one person gets 5 cookies. So you can even see this, where this would be 1 person gets 5 cookies, 2 people get 10 cookies, 3 people get 15 cookies, 4 people get 20 cookies, and it goes up and up and up, and that's a consistent rate of change. Okay, sales, items sold, and the price. So our initial, if we look at this, our initial point is at 0.36. I'm going to put this as our point, 0.36. And then our final point is at 12.0. So when we subtract our vertical change, it really is 60 minus, or actually it's 0 minus 60. So I'll put that here, 0 minus 60, because our final position of Y is at 0. And then our X goes from 12 to 0. So 12 minus 0. So when I do this, I have negative 36 over 12. And when I simplify this, it is negative 3 over 1. Negative 3 over 1, which means this negative shows that my rate of change is going down. It has a negative change. Okay, so that negative actually indicates something to us. All right, looking at the back. So now we're comparing the rate of change for 2 lines. And so really what we're doing is we're looking at each individual line, and then we're making a calculating the rate of change for each one and comparing the two. So if you look at this example here, there's a graph where you have Joseph's heart rate and Layla's heart rate. And I don't know why it's not letting me move over here at the graph, but basically we're going to find 2 points. So the picture here in the in that, let's see, where's my writing? Okay, so here's, if I were looking at the points that they chose, I think the initial points right here, this point and this point, and then they found, I think, like a point where they were both in the same, like X maybe, but, or maybe they use different points. Anyway, so I think the first point was at 135. And then 65 and 1. So 65 is right here. Oh, that's right there. So this graph is kind of hard to see because it's so small, but they calculated the rate of change, the change in Y over the change in X, subtracted it and simplified it. So for Layla's heart rate, it was about 35 beats per minute. And then for Joseph's heart rate, it was about 45 beats per minute. So think about who has a faster heart rate. Well, it looks like because Joseph has more beats per minute, his heart rate's going faster. So let's take a look at these two problems here. Time is going to be the same for both beakers. I guess we're taking a look at maybe a science experiment where we're seeing what beaker heats up faster or cools down faster. So let's say Ned boiled 2 beakers of water. He put beaker 1 in a pot of cold water to cool. The table shows the temperature in the 2 beakers. Compare the rate of changes. So one of them he puts in cold water, the other one he just lets cool gradually, okay? So if we're looking at the rate of change of beaker 1, let's label our work so we know exactly what we're looking at. So beaker 1, the rate of change is the change of Y. So these are like those Y's that we're looking at, and the time stays the same for both of them. So the final position it's at is at 88 minus 100. And then for X, it's at 3 minus 0. Okay, for beaker 2, that would be 99 minus 100. So only change like 1 degrees over 3 minutes. And then 3 minus 0. Okay, so 88 minus 100 is 12, is it? Negative 12? Negative 12 over 3. So that's negative 4 over 1. The temperature is going down 4 degrees per 1 minute. For this, you have 1 change, negative 1 over 3. And so this is, the temperature is going down 1 degree per 3 minutes. So which, if I were to say, you know, it looks like beaker 1 is cooling down faster, and I would describe where it's cooling down 4 degrees per minute, and beaker 2 is cooling down slower, where it's cooling down 1 minute per 3 minutes. 1 degree per 3 minutes, sorry, 1 degree per 3 minutes. Okay, so number 2, looking at our chart. Big thing here is just finding 2 points. 0 is easy to work with, so we could put that as one of our points. 0, 0 is the initial chain part, and then let's use this final point. So if I look at this point, car 1 is at 8:60, 8 minutes and 60 minutes, or 8 seconds, takes 8 seconds to get him up to 60 miles per hour. Car 2 is at 8 minutes, but it goes up to 40 miles per hour. So in 8 minutes, it goes up to 40 miles per hour. So looking at the graph, you can already tell which car is faster. But let's compare their exact rate of changes. So car 1, we would do that final spot, 60 minus the initial position it was in, and then 8 minus 0. And so you have 60 over 8. And then car 2 is at 40 minus 0 over 8 minus 0. And so it's 40 over 8. And this would be 5. This one I need to calculate. So it would be like 7.5. Let me write it just as a decimal. 7.5 over 1. Okay, this is 5 over 1. So this is basically car 1 is describing that it goes up in speed 7.5 miles per hour per second. And at 1 second, it goes up that fast. And then car 2 goes up 5 miles per hour per 1 second. And so we could say, well, car 1 is definitely faster because it's traveling further in 1 second. And so when you add up those seconds, car 1's going to be way faster. Okay, and that's basically all you're doing. You're just comparing the rate of change between either 2 items or just looking at 1 item and describing the rate of change. That's it.